Welcome to this lecture number 3, lecture topic Mechatronics Measurement, presented by Dr. C. Manivel, Assistant Professor, Mechanical Engineering. In this lecture, we are going to discuss about what is system, measurement system, the classifications of open loop and closed loop system, and finally, what is automatic control system. Let us discuss one by one. First of all, we have to understand about what is a system. The word system refers a physical components arranged in a sequential manner to form a unit to perform any task. Let us take it as an example as universe. Universe as a systems. Universe having many subsystems. Likewise, we will take it as a human body as a systems. Human body having many subsystems like nerve systems, brain and diagnostic systems, etc. Likewise, here we will take it as a practical examples of motor as a systems. Motor having many elements that arranged in a sequence manner. Here input device as well as the output devices. Here the input electrical power is provided to the motor that will provided as a rotational output. Here we are not concentrating on what type of data is going on inside it to the motor. We will concentrate only on output and input devices. Right. So this is the examples for understanding about the system. Next one is measurement system. Here the measurement system may be many mechatronics elements. Here the input, again the sensor or transducer, then signal processor, then display or recording devices, finally as a output. Here the input quantity being to be measured that will provided to the sensor or the transducer unit. That sensor or the transducer output to be provided to us a processing unit in terms of digital form. Based on the signal processor output, the output may be provided to us a display unit or the recording devices. The final output, that is the magnitude of measured quantity in which form we record, that will received in the output units. Here we will take it as an example of digital thermometer shown here. Here the thermocouple is the sensor or the transducer. That output to be provided in terms of amplified signal to the signal processing unit. In that signal processing unit, analog to digital converter, the convert the values which we provided from the thermocouple to the processing. That processing unit provided the output as digital form that will be displayed in the LED display units in terms of Celsius or the Fahrenheit, equivalent value of digital forms. The thermocouple is a transducer here that converts temperature to a small voltage. That voltage level displayed in terms of digital form. The amplifier increases the magnitude of voltages. The analog to digital converter is a device that changes the analog signal to a coded digital signals in the signal processing unit, and the LEDs are displayed in the digital values of the temperatures, which is measured from the thermocouple unit. Control system. Control system in mechatronics refers to a group of physical components connected or related in such a manner to command or direct or regulate itself or another system. The physical components may be electrical, mechanical, hydraulic, pneumatic, thermal, or the chemical in general. So these physical components connected or related in a sequential manner to control it or command it or direct it to the another system is called it as a control system. Here some of the difference points between the open loop system as well as the closed loop systems are shown here. Based on this, we will have a more understanding about the difference between open loop system and closed loop system further. Here in open loop system, having or using a not using a feedback loop. In closed loop system, having a feedback system or feedback loop. In open loop system, less accuracy, there is no accurate values because of the component or element which input we provided to the systems that directly processing and providing a output as directly. Here in closed loop system, the results may be in more accurate because the many processing components involved in these systems. So the complicated in construction that many number of processing units will make more accuracy outputs in this system. But in terms of open loop system, it is a simple in constructions. There is no complex because less number of processing unit as well as the element is presented here. In open loop system, optimization in control is not a possible because there is no feedback systems presented here. In terms of closed loop system, optimization control is possible. In terms of open loop system, easy maintenance and cost is very less because of the minimized number of components present. In terms of closed loop system, cost is more, it is difficult to maintain because of much number of elements involved in this. Examples of open loop systems are CD disk, digital thermometer, etc. Examples of closed loop systems are automatic water level, washing machine, etc. Based on these examples, we will discuss in elaborate manner further. Open loop system. Here, switch and electric fire is the element we will consider here for the example of open loop system. Okay. So the basic element of the systems are switch and electric fire. Here input is provided to the switch based on the decision to switch is to be going to on or off. According to that, the switch will permit to the input data to electric fire through electric power. Here the output may be a temperature changes. If it is switch is on, the electrical power is making a electric fire. The output may provided us in terms of temperatures. If it is switch is off, the electrical power not provided and it is not making a electric fire, the output may be in not present. So this is the better understanding about the open loop system. The another example we will consider as a automatic bread toaster is the practical applications. In this system, when the system is switched on, the heat element in the toaster may get heat the bread for the particular preset time period, and then automatically it's get switched off and provided the ejected bread from the system. Here there is no feedback of data whether the bread is toasted properly or not. So in this system we are not getting any feedback of the bread is toasted properly or not, though we making a preset value of the toasted time period level. According to that particular time period, the switch is provide a power to make heating the bread. According to that output will be directly we get it from this. This is the examples for the open loop system. Closed loop system. Here the image is shown for our understanding that difference between the open loop system as well as the closed loop systems. Here from these two graphical representations we will make a better understanding about the elements difference between the open loop system as well as the closed loop systems. Let us see from these two. So here that additional element is included, that element name is a comparison element as well as the measuring device of feedback loop. So these two element is introduced in the closed loop systems is additionally. So we will discuss now what is the closed loop system, then how the closed loop system is gets functions according to this. So before that we will discuss about the basic elements which is present in the closed loop systems. Here the plant is the systems or process through which a particular quantity or the condition is controlled. It is also called controlled system. Is measuring unit is the another unit. The sensor or the estimator and signal conditioners or the part is considering as a measuring unit. Control elements are the components needed to generate the appropriate control signals applied to the plant. These elements are also called controller or the control element or the control components. Next unit or the next element is comparison element or the error junction, where the desired system outputs and the measured or the estimated outputs are to be measured or to be compared from the error signal which is provided or get from the output. The error signal is the difference between referred or reference values and the measured value. The correction element or the actuator is the next element. It provides a changes in the plant or the process to be correct in the plant. Next element is the feedback elements. The feedback elements are the component needed to identify the functional relationship between feedback signal and the controlled output. These are the basic elements presented in the closed loop systems. Okay. Let us discuss in the closed loop systems. Based on this graphical images, here we make comparison with the open loop system with the closed loop system for more understanding. Here what input we provided to the system, that is switch, that input data present either on or off. According to that, the switch will functions in the open loop systems, but not here like this. Here the input data is directly provided to the comparison element. The comparison element will permit to that input data to the switch in initial stage. Then the switch will provided the electrical power supply to the electric fire. According to that, the output will be provided. Here the input is required the preset values. The preset values already set in that. According to that, which kind or what kind of output level we are expected from this unit, that will provided as or measured from the output unit. What kind of output produced by the electrical fire, that will measured from the measuring devices. That feedback will be provided to the comparison element. That comparison element will compare how much unit of input we provided to the switch, then how much unit of output we received from the output. That level will be compared in the comparison element. If there any error or the difference presented in that error will be measured in term through the feedback signal. That error to be reduced or rectified in the comparison element. Then the further the level will be provided to the switch, so that we will attain the expected output in the output element. This is the functions of the closed loop systems. Okay, the additional element of comparison element as well as the measuring device of feedback signal will make precise output in these systems accurately. So already we discussed about the basic elements of a closed loop system, which we presented here. The images shows for more understanding about how the basic elements are making in a sequential manner to form any plant or to performing any process outputs. Here the basic elements are comparison element, control element, correction element, process element and the measurement elements. So these are the basic 5 elements required to making a perfection in the any kind of automatic process. Thank you for your listening. Thank you.